In this video, I'm going to sum the forces that are acting on a block that is being pulled by a force that is above the horizontal. And fighting against that is going to be the force of kinetic friction. So I'm going to go ahead, I'm going to sum up my forces. So I turn the block into a free body diagram, just a point particle. Going horizontally is that original force, better label that original force in the x direction. Fighting against that is the force of kinetic friction. Going down is the weight of the block, and going up is normal force. Now, looking at that, I'm going to add up my forces. So I have sigma F. Get my arrow. Well, let me make my arrow. Let me erase that. Move it down a little bit. Sigma F equals MA. And the next line, I'm not going to worry about the arrows because my pluses and minuses are going to tell me my directions. So I have the force acting in the x direction minus the force of kinetic friction equals mass times acceleration. The force in the x direction is the force that was pulling the block, cosine of that force, minus the coefficient of kinetic friction times the normal force equals MA. And then I do my next substitution. The force that's pulling in the x direction, cosine of that angle, minus the coefficient of kinetic friction. Now, the normal force is going to be the weight of the block minus the force in the y direction. Well, let me take that off. Minus force sine theta. And I'm going to have to move this down here, equals MA. So in the next screen, I'll go ahead and rewrite that all out so you can see it. So it's the force in the x direction, so that's cosine theta, minus the coefficient of kinetic friction. Now the normal force was the weight of the block, the earth is pulling down, and a piece of the rope is pulling up, equals MA. Okay, done.